Hello everyone, I am Yichi Ho. I am a manager at the Industrial Technology Research Institute, also known as ITRI in Taiwan. I work in the Green Manufacture Technology Division, focusing on thermal management and cooling technologies for high-power electronic systems. In recent years, we have focused on developing water-based immersion cooling systems for AI and high-performance computing applications. These systems aim to solve the challenges of high heat generation and improve system efficiency. Today, I am very happy to share our work with you. I hope our technology can provide a simple, green, and effective solution for future computing systems. This slide shows our water-based immersion cooling technology. In this system, electronic components are directly placed in water. This allows heat to be removed quickly and efficiently. Compared to traditional air cooling, water can carry much more heat, so the cooling performance is much better. Our system is designed for high-power chips, especially for AI and high-performance computing. A single chip can generate up to 2,000 watts of heat, and the heat density can be higher than 300 kilowatts per cubic meter. This level of heat is very difficult to handle with conventional cooling methods. One key advantage of our system is the use of water as the cooling fluid. Water has a very high heat capacity, which means it can absorb a large amount of heat and keep the system stable. It also helps reduce temperature fluctuations and improves system reliability. In addition, our design removes the need for complex piping systems. This helps reduce system cost and makes the system simpler to build and maintain. We also combine the system with a heat exchanger and natural cooling sources, which can greatly reduce energy consumption. Another important advantage is that water is environmentally friendly. It has zero global warming potential, and it is easy to recycle. This makes our solution green and sustainable. Overall, our water-based immersion cooling system provides a safe, efficient, and scalable solution for future AI and HPC systems. Here shows why we choose water as the cooling fluid. We compare water with chemical fluids in several important areas. First, water has much better cooling performance. It can handle very high heat, including chips over 2,000 watts. Chemical fluids, on the other hand, are limited when the heat is too high. This makes water a better choice for future AI and high-power systems. Second, water is much cheaper. It is easy to get and does not require special materials. Chemical fluids are expensive and increase the overall system cost. This is very important for large-scale data centers. Third, water is better for the environment. It has zero global warming potential, which means it does not harm the environment. Chemical fluids usually have high global warming potential and can cause environmental problems. In terms of safety, water is non-toxic and safe to use. Chemical fluids may have health risks and require careful handling. Water is also easy to recycle, while chemical fluids are difficult to recycle and dispose of. Finally, water-based systems are simpler. They do not need complex piping or sealed systems, so maintenance is easier. Overall, water is a more efficient, safe, and sustainable solution for immersion cooling. This slide shows how we move from design to real system and final validation. It proves that our technology is not only an idea, but a working solution. First, we have strong design capability. We created a complete system design, including the structure, piping, and cooling layout. This allows us to build a full system, not just a small test setup. Next, we built a real prototype system. As you can see in the picture, the system includes multiple immersion tanks and control units. This shows that our technology can be integrated into a practical and scalable solution. We also designed the system to be manufacturable. This means the system can be produced in real applications, such as data centers or AI server environments. Most importantly, we have completed long-term validation. We tested the system for over 180 days to ensure stability and safety. The results show no leakage and stable operation over time. Finally, we verified the cooling performance. Our system can handle more than 2,000 watts of heat. The temperature remains stable, which proves that the system can support high-power chips. In summary, we have completed design, built the system, and successfully validated its performance. This makes our solution ready for real-world applications. What makes Taiwan an ideal hub for developing water cooling technology? First, Taiwan is an island, so it is surrounded by a large amount of seawater. This means we have easy access to a stable and continuous cooling source. In addition, Taiwan has a subtropical climate, which brings a high amount of rainfall every year. Taiwan also experiences frequent typhoons and seasonal monsoons. These weather conditions bring a large amount of fresh water. As a result, Taiwan has many rivers, reservoirs, and groundwater resources. Another important factor is Taiwan's geography. The island has many mountains, which help collect and store water. This water is then directed into reservoirs and rivers, making water resources more stable and reliable. Taiwan also has well-developed water infrastructure. This includes dams, reservoirs, and water management systems. These systems make it easier to use water efficiently for industrial applications. Because of these advantages, Taiwan has access to both fresh water and seawater. This makes it very suitable for water-based immersion cooling systems. Taiwan has natural and infrastructure advantages that support the development of efficient, sustainable, and large-scale cooling solutions. In summary, our water-based immersion cooling system provides a simple and powerful solution for next-generation AI chips. We have demonstrated strong design capability, built a real working system, and successfully validated its performance, including over 2,000 watts heat removal and 180-day long-term testing. Compared to traditional and chemical cooling methods, water offers better performance, lower cost, and zero environmental impact. In addition, Taiwan's abundant water resources make this solution highly practical and scalable. We believe this technology is ready for real-world applications and global collaboration.